All right, guys, this is now your lecture for Conservation 102 on lake ecosystem, lakes. Lake ecosystems. Guys, hey, come on. Lake ecosystems. Okay, we refer to them as dams. Remember, the dams. These are beautiful pictures of some lakes. However, be warned. So we have large lake ecosystems throughout Africa. They're not very common in South Africa. But we have many of these dams. But remember, the structure is called the dam. The dam is what causes the blockage. What forms behind it is we refer to it as the dam, like this is Kariba Dam, but it's not. It's actually a man-made lake. It's a lake that is made by man because of the dam. So the dam is the feature, but it's the lake behind it. So this is lake ecology, because the processes that occur in this lake are similar to the processes that occur in this lake, which is Lake Victoria. Then we also have other lakes along the coast. You can see here by the sea. You have lakes, natural lake ecosystems that form by the sea, and I'm going to show you why in a moment. And then we know about these small ponds or lakes in Kruger, hey? But you've got to be careful. What is a lake? Today we are talking about what is a lake and how does it work. Okay, rivers. Rivers are called lotic ecosystems. Lotic referring to flowing water. Okay, they're flowing water concentrated in a distinct channel. Open water bodies that are permanently inundated are called lentic ecosystems. Lotic refers to rivers, lentic refers to open water bodies. However, a lentic ecosystem has to have a certain depth, and that depth is a minimum of 2 meters. So all ecosystems that are like a lake, that reach a depth greater than 2 meters are called lentic or lake-like ecosystems. Lentic means lake-like, limnetic. Lentic or limnetic. Oh, lentic ecosystems where there's standing water, lentic ecosystems where there's standing water, and limnetic is a lake-like ecosystem. Very similar. Lotic, lentic, limnetic. Lotic, rivers, flowing water, lotic. Lentic, still standing water bodies. Okay? And limnetic is still standing water bodies that are deeper than 2 meters. They look like lakes, lake-like ecosystems. Lotic, lentic, limnetic. Lotic, lentic, limnetic. Lotic, lentic, limnetic. You with me? Lotic, what is lotic? Flows. Lentic, standing. Limnetic, limnetic, lake-like ecosystem. Has to be deeper than how deep? 20 meters. 2 meters, 2 meters, 2 meters. Then you get wetlands. Wetlands are lotic. No. Okay, remember, don't be confused. We refer to all wetlands as inland systems. Do you remember we had that problem with the definition of a wetland? However, in South Africa, you've got a choice. You can call it a wetland, or you can call it palustrine ecosystem. What do you want to do? What do you want to use? Wetland or palustrine? Wetlands. We call them wetlands, okay? Wetlands is a specific group of ecosystems that are transitional between terrestrial and aquatic. They are lentic, standing water, but they are shallower. They are not so deep. If it's more than 2 meters, it is limnetic, it is a lake. If it is less than 2 meters, it is a palustrine or a wetland. Yes, ma'am.
What is the difference between aquatic and a marine lake?
No. Marine is aquatic.
Okay.
Where did you see that? Aquatic is terrestrial. Hey. Guys, it's going to be your turn in the exam. You laugh at her, like this. Hey! Guys, please. Okay, so all wetland, water-based ecosystems are called aquatic. But terrestrial ecosystem and aquatic ecosystem can only be compared when you're comparing terrestrial landscape, inland aquatic ecosystems, or terrestrial landscape and a marine aquatic ecosystem. But these bodies are all inland. Inland. They are only inland. You do not, that is a good question, because is the sea a lake? Why not? Because it's the sea. you understand? Why? Because it's not inland. It is a marine ecosystem. So that's actually not a bad question. That's a good question. Wetlands. Okay. So what is a lake? This is important. The definition of an inland system includes inland aquatic ecosystems, not just wetlands, lakes and other water bodies, like these different lakes. Lake Funduzi. Who knows of this Lake Funduzi? Yeah, it's a real inland lake. It's natural. It's not a dam. They are true lakes. Bass Lake, for example. They're considered to be types of inland systems in terms of the classification system. What classification system are we using? The SANBI, South African National Biodiversity Institute classification. I don't want you to remember South African National Biodiversity Institute. I just want you to know that the classification system you're using comes from South Africa. It's our own system. This system is being used throughout Africa, thanks to some of us who are sneaky because we're too lazy to come up with a new one. So we tell them, please use this one. Even if they are artificial, such as a dam. A dam is what causes the wall. But guys, if I start talking about the Vaal Lake, people are going to say, I don't know what you're talking about. Common names are referred, when they give the name the Vaal Dam, even though we know technically it should be called the Vaal Man-Made Lake, people don't know what you're talking about. So just think about the people and say, oh yes, I'm talking about the Vaal Dam. You understand that? Yes, I'm talking about Kwena Dam. I'm talking about Pine Lake. Pine Lake is actually called the lake, which is right. You should classify open water bodies as depressions. Wow! So lakes form in depressions. What is a depression? It's when somebody is depressed. No. It is a hollow area in the ground. Do you understand? A depression where water can go in and fill up that area. You can create a depression. How do you do that? You build a wall and you create a depression. You understand? And then that depression can fill up with water. This rule is based on the fact that landform characteristics such as systems fit the definition of a depression, that they typically have a closed or near closed elevation contours. So it's like a bowl. A bowl is closed. You see, the water can go in and fill up. Okay? Has to be of a certain size. Perimeter to the central area of the greatest depth. The lake and other open water bodies that have a maximum depth greater than 20 meters. No. How many meters? 2 meters. Are called limnetic systems. Limnetic, lake-like ecosystem. Okay, where do they form? They can form all over the place. You can have them on benches. You can have them a part of the river systems if you create a depression by putting up a wall. Lowland areas as well, these depressions. Do you understand? Dams or lakes can form in different places in the landscape. Depression in an aquatic ecosystem with a closed or near closed elevation contours increases in depth from the perimeter to the central area. So depression usually is shallow on the sides and it gets deeper towards the center generally, okay? But a depression is like a big bowl. Okay, like a big bowl. So guys, if you build a small weir, okay, a small weir on a river, creating a small depression so you can gauge it, but the river just goes straight over it and doesn't get deep enough, it's not a dam. You understand? It's just part of the river. Okay, dominant water sources are precipitation, groundwater discharge, inflow from upstream, diffuse or concentrated overland flow. Okay, where does the water come from? Upstream, rainfall, groundwater discharge or recharge from the bottom. Groundwater can fill up lakes and keep them full. Interflow and overland flow. What is the difference between a lake and a pool? Well, if you do not have a depression, you can have pools inside a river. You understand? Many pools. But they are not generally closed. You see this near closed. Closed or near closed. It's not closed or near closed. You see? It's just a part of a small depression inside the river. It's got open ends. So you can't call that a lake. That's a pool. Remember the biotopes that we looked at last week, the pools. Dominant hydrodynamics. The dominant water flow characteristics are primarily seasonal. So even in lakes, you have water flow. Because of our seasonality in Southern Africa, we have lots of rain in summer. These lakes fill up. The rivers fill them up, and then in winter they get clear and they get deep, or they are deep but they get clear, and then they start to get shallower and shallower. Hey? That's the characteristics of lakes. They can be flat-bottomed, referred to as pans, or round-bottomed, and may have a combination of inlets and outlets or lack of them completely. A system that has no outlet is called endoheric. Endoheric, meaning all the water ends up and goes into itself. Endoheric, like a pan, there's no outlets. Okay, a dam, when it fills up and the water overflows, the outlet is the dam wall, overflows, or the spoolway. But some systems have no outlet. They flow into a point and they go into the ground. Finished. Remember, the important things is that a lake has to have a closed or near closed depression, has to be confined by something, and for it to be limnetic, has to be deeper than 2. Well done. Okay, for purposes of the classification, natural lakes, including coastal lakes and dams, are typically drowned valley floors. They are considered to be depressions. So when you find a valley floor that is inundated by more than 2 meters, we consider that to be a depression. So in other words, you're going to struggle in some areas because you'll say, you know what, this doesn't really look like a depression, but it's 2 meters deep and it's quite large. It's a lake. You can call it a lake. Okay, this is a type of pan ecosystem. Hey guys, this wetland ecosystem, or this ecosystem, occurs around Chrissysmeer. If you drive on the Highveld towards Vosloorus, I think it's called, towards KZN, we often go past this area. You have many of these ecosystems there, lots of shallow depressions, but the water depth does not reach 2 meters. So what are they called? In other words, is this a lake or what is this? It's a wetland. Okay, this is a big pan. This is a big pan. Now we're moving on to the processes of lakes. So we talked about what it is. Okay, let's talk about their processes. Large lakes can naturally occur but are commonly associated with the construction of dams in South Africa. Due to their size and the extended open water areas, lake ecosystems establish various zones driven by light, depth, and temperature. Guys, please, this is so important. This is something that you guys really struggled with last year. Okay? We are going to talk about the zonation and the layering of different parts of the dams based on 2 things: light and temperature. Light and temperature. Okay, 2 things that cause the zonation of dams or lakes: light and temperature. 2 different things. Please, let's remember that. Which affects substrate, gradient, climate, water chemistry, and types or densities of plant communities. This is a picture here to show you, if you consider light. The light penetrates to this the bottom of the light penetration zone, or the light compensation level, where light can penetrate in water. Plants need light to grow. Do you understand that? Plants need light to grow. Below this light compensation level, plants cannot grow because the light doesn't reach there. Do you understand? And because lights do not grow there, the plants are not producing oxygen. So below this level where you don't get light, you get an area called the profundal zone. And in the profundal zone, you generally do have very, very low oxygen levels, or it is anaerobic. There's maybe no oxygen at all. Because even though light doesn't come down here, all the material that's in the lake can come and settle out here anyway. But because there's no light, there's no green plants. And because there's no green plants, there's still bacteria. And bacteria is anaerobic. Bacteria produce CO2. You understand that? They produce carbon dioxide. So these profundal zones are not a nice place to live. There's no oxygen. Hey? There's no plants. So fish need oxygen to survive. Can they go live in these deep profundal zones? No. So when people go fish, they think, deepest part of the lake. Hey? And they're fishing in here. Catching nothing. You understand? And then they say there's no fish in this dam. Meanwhile, the fish are here. You understand? In this layer here. Okay. The limnetic. What is a limnetic ecosystem? Limnetic is a lake-like ecosystem. So why do they call this the limnetic zone? Hey? This is a zone, so you've got a limnetic zone and a profundal zone. The limnetic zone is the lake, the living part of the lake. Okay, the limnetic zone. So please don't confuse it with a limnetic ecosystem. Limnetic zone is the living part of the lake compared to the profundal zone, which is the deep, stagnant, dead part. We don't want that part. You with me? Okay. Then, littoral zone. Okay, you get plankton. This is just to show you here that plankton also uses light. Plankton is a type of algae, that grows. It needs light. The picture here is to show you that you do get some fish going down there, but it's not a good place, because there's very low oxygen levels. So they may go down there and they may feed, but then they probably come up again. Then this benthic zone. What is benthic? Anybody have an idea what benthic means? Benthic means the bottom. It's like saying, can I say this? You're going to land on your benthic. You're going to land on your bottom. Okay? Oh, good, we've got time. Okay, benthic is the substrate, the substrate zone. Okay, this zone. So the benthic zone is the bottom zone. The benthic zone, you can have a benthic part in the littoral zone where the light can penetrate. You can have a benthic part in the profundal zone. You see, benthic. It's the same thing. You with me? The littoral zone is where you get this light that penetrates. Okay, the living part of the lake. Then you get the profundal zone, the deep part, that's stagnant. Okay, Newston, don't worry about it. Newston refers to animals that live on the surface. Newston, Necton, animals that live on structure, and benthos. But don't worry about those. I don't want to confuse you anymore. Okay, let's see. Littoral zone, benthic zone, limnetic zone, or the open water from the surface of the water to the depth where oxygen production and consumption are balanced due to light penetration. Profundal zone, area below the limnetic zone, where lack of effective light penetration causes more oxygen to be consumed by respiration than produced by photosynthesis. It is not a nice place to live. All right. Any questions on the zonation of lakes based on light? This is the zonation of lakes based on light. Please remember the sun when you associate yourself with these things. Okay, light. Light does it. If the lake gets turbid, the littoral zone can get smaller and smaller. Okay, so guys, there is an alien fish called a carp. Carp that comes from Europe. What carp do is they go into the mud and they dig, causing the mud to come up. And because mud gets into the water, the littoral zone of lakes gets shallow and shallow, almost disappearing because of a fish species. And then we start to lose other species because they cannot see their prey. You see? So even species like an alien carp can affect this littoral zone. And based on the zonation of lakes, based on light, they can affect the ecosystem. Bass fishermen hate carp. Why? Because bass need light to feed, to find their prey and to catch them. And if you have carp, there's too much sediment in the water. The littoral and limnetic zone is very shallow. And because of that, they don't get much bass. They don't get a lot of fish. Okay, next one. Lakes also can be, the zonations of lakes can be affected by temperature. This is the second one. And here you have, has anybody ever swam in a lake where you think of the top is nice and warm and the bottom is cold? Yeah, that is because of temperature. And you have this limnion, thermocline, hypolimnion. Limnion is on top, hypolimnion is below. Thermocline means temperature divide. Temperature divide, thermocline. So it's just 3 levels: epilimnion, thermocline, hypolimnion. Okay. Now, why do these layers form in lakes? Why? Why do these layers form in lakes? Hey? It's temperature, but what has temperature got to do with how this can happen? How does temperature affect the different layers of lakes? Because if one layer goes to the bottom, what does that kind of tell you? if the layer goes to the bottom, why is this layer on the bottom, not on the top? Why doesn't it mix? Why is it forming? Why is there layers forming? Because of temperature. How come if this one's colder than this one, it doesn't? It's separated. Why won't it mix? Yes? The lake doesn't move, but what makes it go to the bottom? What makes a stone go to the bottom of a dam? What? Someone throws it. But when I throw the stone, if you skim a stone, if you throw it on the surface, why doesn't it stay on the surface? Because it's, hey? It's heavier. It's heavier. I want to keep it simple. It's heavy. So cold water is heavy. Cold water is heavy. That's why it separates like this. Okay. Listen, wait, this is very important, guys. Today you're going to learn something very special. Today you're going to learn something very special. So, guys, what about ice? Ice floats. Is ice heavier than water? But I told you that as water gets cooler, as water gets cold, guys, it gets heavy. So how come ice floats? Guys, listen to me. Yes, we have an answer.
I think because ice it has some small pores where air is free, and that's why
It's full of what?
air.
You are correct, but for the wrong reason. How does it get the holes? How do you get holes in water? How do you get holes in water? Hey? So you think the oxygen in water breaks off? Because remember, water is H2O, hydrogen and 2 oxygen. It doesn't break off. It doesn't break off. So how come he's right? There is lots of gas in water. There's lots of space in water. Hey? By the way, water also gets bigger. Have you ever put a Coke in a glass bottle in the freezer? Put it in the freezer, what happens? It breaks. Because the ice is actually larger than the fluid. So now there's another problem there. There's spaces in the water when it turns to ice, but it's larger. There's more volume. How can the same thing now become larger when it's ice? Okay? The density changes when it's ice, and then it floats. Guys, because water, hydrogen, H2O, has got a charge on the top and the bottom. You know, with the hydrogen and the oxygen molecules, has a different charge. And like a battery, like two magnets, if you take two magnets and you push their poles together, they repel each other. When you start to condense water, when it starts to form ice, or the temperature gets too cold and it starts to form ice, the ice is being pushed, the water molecules are being pushed together so much that the positive and negative of the actual molecule starts to push each other apart, and it starts to fit into a lattice like a building. It's not all over the place. It's all the negatives are together, all the positives are together, and then it's upside down. You understand? It forms a lattice. It forms a lattice because of the charge. So the charge of water forms a lattice, and because of the lattice, it's increasing in area, and it's starting to create little spaces where gases can fill those spaces. It has to. It has to do that. Guys, that is the property of water that allows us to live on earth. If water didn't do that, we wouldn't be able to live on earth. Because as the seas and the water started to melt, to freeze, it would freeze at the bottom of the sea, and only the top layer of the sea would have a little bit of water to use, and the whole world would be very cold. Do you understand, guys? So that is a property of water that is very, very, very important. You understand? You don't. What's the question? What don't you understand?
What you were explaining.
What we're explaining.
So listen, please, guys. Okay, as water gets colder, let me explain it again. As water starts to get cold, okay, you are starting to push the molecules together to become a solid substance. Ice is solid, hey? Solid. And when it's pushed together to become a solid substance, because of the charge of the molecules have got a positive and a negative charge because of the shape of the molecule, the water molecule. They start to align. They start to match up like bricks. It's not all over the place. It must align like bricks. And because they're aligning like bricks, they're going to push little spaces because it must align. You understand? It must align. And by forming the little brick structure when they get very cold, it has to have all these spaces in it because of the charge. And because it's aligning like that with little spaces, it gets larger and the density is less because it has a lot of spaces, a lot of air in it. You understand that? So if you freeze water, you can see the bubbles in it. That's why your answer is correct. You can see the bubbles in it. But the bubbles come from the aligning because of the charge of the molecules. So as water gets colder, it gets heavier. But when it starts to freeze, it gets light again. That's why you get ice on top. Ice floats. Do you understand now? That's the explanation of why ice floats. Okay, why is this important, guys? Remember, we've got epilimnion, thermocline, hypolimnion. Epilimnion is on top, thermocline, hypolimnion. Which is the lightest? The light blue or the dark blue? The light blue. The dark blue is heavier. Okay. However, what happens when it gets too cold? When a system starts to get too cold, you understand? Then what starts to happen is the water on top starts to get lighter again. Water freezes at 0 degrees centigrade. Between 4 degrees and 0, water starts to get light. So water is the heaviest at 4 degrees. Still liquid. Below 4 degrees, it's starting to freeze. Below 4 degrees centigrade. When it starts to freeze and the alignment starts to occur, it starts to get light. 1 degree water is lighter than 4 degrees. You see that? So what happens? When a system starts to get cold, and even if it's got the layering, you see, this is what we are used to. We are used to 20 degrees on top, thermocline, 4 degrees in the bottom. Then what happens when it starts to cool? The whole thing starts to cool. You get mixing. You see that? We call it lake overturn. Temperature causes the lake to turn. You understand? And then it all is around 10 degrees. It mixes. You see? But as it continues to get cold, now you've got heavy water at the bottom, which is warmer than on top. But only 4 degrees. If the top is less than 4 degrees, then the bottom is warmer now. So I showed you here, guys. The first question was, which is warmer? This one is warmer. This one's colder. But when it starts to get too close to 4 degrees, the top is colder than the bottom. Because water is heaviest at 4 degrees. You understand? Let me explain this again, one more, because this is important. No, let me get to the tropical explanation, then you can relate it more. Let me just go through it. The thermal temperature-based stratification of lakes refers to changes in temperatures at different depths due to the change in the water's density with temperature. So there is a relationship between the density, how heavy it is, and temperature. What is it heaviest? At 4 degrees. Cold water is denser than warm water, and the epilimnion on the top generally consists of water that is not as dense as the water in the hypolimnion, the bottom. However, the temperature of maximum density of water is 4 degrees. In temperate regions, temperate means cold areas where there's snow. We live in a subtropical area. We don't have snow here a lot, huh? So in temperate areas, north of the world, where it's very cold, in temperate regions where lake warms up and cools throughout the seasons, a cyclical pattern of overturn occurs. The lake rolls every year, turns like this, mixes and turns. Now, think about this, guys. The lake's turning. Remember this. So every year, this profundal zone that's got no oxygen and the top zone full of oxygen, the temperatures are causing it to turn. You see that? The temperatures are causing it to turn. Where lake water, a cyclical pattern of overturn occurs repeatedly from year to year as the cold, dense water at the top of the lake sinks. So when this is starting to warm up, when this water here starts to warm up, it goes from 0, 1, 2, 3, 4, it mixes. You see? 5, then you start to get the layering again. 6, 7, 8, 9, 10, whatever. Then you get something like this. 20 and 4. But then when it starts to get cold, what happens? This top layer gets cold, and the heavy water all goes down to the bottom. And as it starts to get cold, this layer starts to increase. This layer comes up. The thermocline comes up to the point where it's 4 degrees, and then the whole thing mixes at 4. You see? Then you start to have ice forming on top. So when ice is forming on top, you know that the lake is turned. When ice is starting to melt on top, you know that the lake is going to turn. Okay, that's in temperate areas. However, what about our area? What happens here? Okay, we're going to get to that in a moment. It occurs twice. So when in temperate areas where ice is forming, the water has to overturn before it freezes, and the water has to overturn after it freezes. Do you understand? That's why you get that overturn twice a year. In more temperate regions such as Southern Africa, lake overturn only goes one cycle. It overturns once per year. But why? Why? Because we have water starting, the top area is starting to get warm, and the bottom area is cold. But as in winter, this area here starts to cool down. And when the area on top starts to get too cold, and it reaches the same amount of density as the bottom, it rolls. So in areas like South Africa, we don't get ice. It doesn't ever get down to 8 or 5 or whatever degrees, but it does overturn because we are changing the densities of the water. You see that? In temperate areas, it happens twice. Why? Because of before ice and after ice. But in Southern Africa, in tropical or subtropical regions, it only happens once. Because it mixes, and then it stays like that until summer, and then you have this forming again. I'm going to show you a better picture now. Wind and other factors can also cause overturn. Wind can do it. Wind. If you have a lot of wind blowing the surface, you're moving the water, you're causing it to turn, you're causing it to roll. And as soon as it gets to a point, it turns. Too much wind can cause it, and that's something that can happen at the wrong time. Okay. Okay, and overturn is important because it affects things like algal blooms, fish kills, and things like that. Okay, overturn causes problems. Guys, remember the lake story we told you last week? Nios, Lake Nios, where all those people died? That was caused by a volcanic activity, which released a lot of gas. That caused the lake to overturn, and the carbon dioxide came out, and it went down into the valley where it killed all these people. Do you understand that? So, wind can cause overturn, but other things like volcanoes can cause overturn as well. Okay, now, overturn is bad, And you see that if there's too much overturn, then you have these type of massive events which are problematic. But temperatures can cause overturn as well, remember? And this is not caused by wind or gas. You agree with me? So in Africa, we also have another problem. Some of our larger, deep lakes, like Tanganyika and Lake Malawi, are very deep. Very, very, very deep. They have a very big hyperlimnion area. Okay? Within the hyperlimnion area, because of light penetration, the profundal area, the profundal zone, which is the bottom of the lake, is full of carbon dioxide. It's been like that for thousands of years. Do you understand? So the amount of carbon dioxide in the lower part of these deep lakes is become dangerous. The levels are dangerous. But it never ever comes to the top. Why? It never turns. Because it's close to the equator where the temperatures are always warm. So it's getting worse and worse and worse and worse until every now and then there's a freak event. like all of a sudden, Malawi area goes through a very cold spell, which is uncharacteristic. And if it allows part of the lake to turn, then all of that oxygen, that carbon dioxide from the bottom of the lake comes to the top and has similar effects. So these type of activities that kill people is not only from volcanoes. It can happen from in these deep lake ecosystems that overturn very rarely. Very rarely. Okay, last thing. This is now, this is my second last slide. What time is it? Good, we've got time. So this is my second last time. This is what's happening in South Africa. Remember we spoke about the epilimnion, thermocline, hyperlimnion. Do you agree? This is probably true that you have temperatures from 22 down to 4. If you stick your oxygen, your temperature meter into the water, you can see how it changes as it goes down. So how do you determine if there's stratification like that? You just measure the temperature at different depths. Even our dam here stratifies like this. Okay, epilimnion, thermocline, hyperlimnion. Then what happens? In autumn, in autumn, the whole thing starts to cool down. And because the top is getting cold, you start to have the whole mix. You see, the whole dam mixes. Yeah, they're suggesting it happens twice as well, but it doesn't. We only have it once. I think the reason being is because here they're just suggesting that it gets too cold. It gets down to 4 degrees. Where what happens is, as it cools down in winter here, so we go more from an epilimnium structure like this. You see, they're saying that we have temperatures that go from 4 to 0, which we don't have. Remember, so this is more of a temperate thing. So what we have is we go from this layering into winter where it mixes in winter, and then at the end of winter it starts to layer like this again. Do you understand? So in our area it only goes from this shape to mixing back to this shape, to mixing back to this shape, to mixing back to this shape. You see? Okay. Good. Please, you need to understand that. So remember there's two things that cause lake zonation. The first one is based on light. Okay, littoral zone, profundal zone, limnetic zone. Then you have another one based on temperature. Limnion, thermocline, hyperlimnion. Do you think that this epilimnion and the littoral zone are the same? So the light penetration depth is the same as this epilimnion depth? No. No, 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 no. They are not the same. Sometimes light can penetrate way below the thermocline and there can be plants growing here. Do you understand? So they are completely different. But remember, because you cannot see this thermocline, by the way. You can feel it. If you get into the water, you can feel it. Sometimes I was saying when you're swimming, the top is warm and the bottom is cold because your body is going between this. Then you feel, it's cold down there. Stay on top. Okay, great. What's important about this? This is the last one. Lake overturn and resulting mixing of zones of a lake affects the stability of water temperatures. So, organisms that live in water are very vulnerable to changes in temperature. Remember, if I'm at nice 20 degrees and I'm having lots of fun, and all of a sudden there's a big storm or wind that causes the lake overturn, and it drops from 20 to 10, we'll all die. We'll die. We cannot tolerate the changes. Especially in our area, guys, because a lot of our fishes, they go live in lake ecosystems that are not natural. Dams are not natural. We've created the dams. And now in our dams, we say, don't worry. Don't worry about it. The dams will give more habitat for more fisheries. The dams will provide more opportunities for the fish. It's better. But the fish do not have the ability to survive in a dam because of overturn. So all the fish that go into the dam die. Then more fish come into the dam, die. More fish come in, die. Die, die. So the dam, not only the fact that you're creating a barrier, but because of the overturn, it can be even worse. Do you understand that? It can be even worse. Okay, oxygen levels as well. Remember with the layering, littoral zone is nice and highly oxygenated, limnetic zone. Profundal zone has got no oxygen. And if the zones are separated for too long, and there's change all of a sudden, the oxygen levels can go from high to low overnight and kill everything. You understand? So I'm dealing with the oxygen. Then I'm dealing with the temperatures. It's just too much. Okay. What about sediment characteristics as well? Remember from the story, the guy said he came back the next day and the lake was brown. The lake was always nice and blue. He came back and it was brown. Because when it overturned, that movement of water turning can also kick up the sediments. And now I can't find food. Now the plants can't grow. And we all die. You understand? Natural ecosystems, the organisms that live there in natural lakes have the ability to tolerate those systems. But if you create an artificial dam, especially in a temperate area, you get lots of species that are not able to cope with those low temperatures. So the aliens do well. The aliens can survive this. Local species can't. You're going to lose plants when it overturns because of the sediment. You're going to lose oxygen when it overturns. The temperatures are going to change very quickly when it overturns. Bam, bam, bam. Dead. Okay, by Christmas. Okay, some species are resilient, but not in our region. Most of them are aliens. Some animals do not have the ability to respond to changes in water quality fast enough to leave, or they must just die. Some of them try and get away. Okay. This is of particular concern in artificial lakes with dams where fish kills and other natural ecological events are often observed. To minimize the negative effects, you can release water from the dam to keep it shallow. You can also release water into the dam to keep it mixed. You can do some things. Okay. So you don't have to just live with it to affect the effect of lake overturn. Guys, this picture, these fish, by the way, are yellowfish. This is from KwaZulu-Natal, from the Duzi River. Has anybody heard anything from the Duzi River? On Thursday last week, this is not from lake overturn. This is from a chemical spill. Okay? These fish are about between 12 and 18 years old, all of them. Okay? And they were all killed over the weekend, as in Friday, Saturday. This happened Friday, Saturday. This photograph was taken on Saturday. Huh? They think that they've destroyed all of the aquatic life from Pietermaritzburg right down to Inanda Dam. Hey? About 45 kilometers of the Duzi River and the dam. They've killed everything. And why? It was a food company who had one of their containers full of oils burst. And when it washed away, it took soap, like your soap for your washing, and it pushed it into the river, and that has caused this massive fish kill. And they've killed just about everything. And I had a few students doing work here. All of their animals are dead. Okay. You see, this is happening around us every day. The importance of understanding and managing these systems is up to you guys every day. On the N4, if you go on the N4 towards Johannesburg, you go past that big sappy plant. In 1989, that plant had a big effluent spill. It killed everything from Mngudwana right down to Nelspruit. Everything. Today, we are still trying to see the recovery. Today, it is still recovering. All right. Guys, that is it for lake ecosystems. Listen, please listen. Please, you need to go over these lake ecosystems. You need to learn it and understand a little bit better. We're not having class tomorrow. We're having class again on Thursday. I'm going to start with estuaries on Thursday. Already, I'm going to start with estuaries. And hopefully, I'm going to have a little bit of time next week to recap and just go over your course content and to give an idea of what's going to be in your exam. Next week, you're writing your class test. Okay, please, you need to start learning. For zoo, you need to start your pracs. Guys, you need to finish this term off. You need to finish the term off.